Ever wondered how you can work out the speed of a tennis ball after a serve? Well, today I'll show you how, along with how to use these equations to solve different types of impact problems. Let's start by having a look at a bullet fired into a piece of wood. We need to work out the deceleration of the bullet first, then the impact force, and finally how far it goes into the wood. First, list the equations you might need to use to work out the acceleration. We have the famous F equals ma, the definition of acceleration, a is v minus u over t, and the motion equation, v squared equals u squared plus 2as. All of these have an a in them, so might be the one we need to use. To select the right one, let's have a look at the values given in the question. We have u is 100 metres per second, v is 0 metres per second as the question says the bullet stops. We also have mass is 0.02 kilograms, and the time for the impact is 0.005 seconds. So in F equals ma we have the mass, but not the force or the acceleration. So it's not F equals ma, as we need all of the values in the equation apart from a. In the acceleration equation we have v, we have u, and we have t, everything apart from a, so this is the one that we can use. We can't use the motion equation because although we have v and u, we don't have a and s. And because we have a missing and s missing, we can't work out a. Let's use a is v minus u over t. We write the equation out and then substitute in our values. So v becomes 0, u becomes 100, and t becomes 0.005. Pop that into your calculator and you'll get the acceleration is equal to minus 20,000 metres per second squared. The minus sign is just there to tell you that the acceleration is actually a reduction in speed, so effectively a deceleration. Now, as the question is worded that they want a deceleration, we do not need to write the minus sign. So when we write the answer, we will just say that the deceleration is 20,000 metres per second squared. Also, when you're writing the units, don't forget the squared on metres per second squared, otherwise you may lose a mark. Now for part B. As we have the acceleration and we need to calculate the force, we can go back and use F equals ma. Write out the equation, F equals ma, then substitute in, so m becomes 0.02 and a becomes 20,000. Pop the numbers into your calculator and you will get 400 newtons. Alternatively, you could use the impulse equation instead. So the force is equal to the mass multiplied by the change in velocity and divided by the time. Substitute your values in here, so m becomes 0.02, delta v becomes 100, as the change of velocity is 100 minus 0, and the time t is 0.005 seconds. Again, this gives you 400 newtons. Neither way is better than the other, it's just whichever one happens to come into your head when you're solving the problem. For part C, we now have all the values that we started with, plus a force of 400 newtons and an acceleration of minus 20,000 metres per second squared. To get the distance travelled into the wood, we can now use the motion equation, the only one we haven't used so far, as we know v, u and a now, and only have to work out s. Write out the equation and then substitute in the values. So v becomes 0, u becomes 100, a becomes minus 20,000. Then do the calculations. A big problem here is people forget to square the v and the u, so double check that you've done that. The calculation should become 0 is equal to 10,000 minus 40,000 s. Then we can rearrange this to 40,000 s is equal to 10,000, so s becomes 10,000 divided by 40,000, which is 0.25 metres, or 25 centimetres. Hopefully you can see how we have to be flexible in how to solve these problems. And if you're stuck, I've given you a process through which you can go to identify the correct equation that you need to use. Remember, write down what you've got and then go through the equations that contain the letter for the value that you want to calculate. If you're finding this helpful, please like, subscribe and hit the bell to be notified of my next video, and check out my other videos on forces. Now to the question that we started the video with. How do you work out the speed of a ball after a tennis serve? Let's list the variables we know. The mass is 0.057 kilograms, the force on the ball is 125 newtons, and the impact time is 0.0228 seconds. And the initial velocity is 0, as we're told that the horizontal speed of the ball is 0 at the start. and we want to work out V. As this is an impact problem, let's look at the momentum equations first. We can use P equals mv to calculate the initial momentum of the tennis ball, but that doesn't give us the final velocity. So let's look at the other equation. Force is equal to the mass multiplied by the change of velocity and divided by the impact time. If we write this out in full, we have F, we have m, we need to work out V, we have u, and we have t. So we can use it to work out V. Substitute in the values and we get quite a complicated expression. If we multiply both sides by the time of 0.0228, that will simplify it to give 2.85 is equal to 0.057 V. Then V is going to be 2.85 divided by that 0.057, which gives us a final velocity of 50 metres per second. A very fast tennis ball, definitely Wimbledon worthy. The final type of question I'm going to look at today is a car collision. Here we'll need all our ideas from the momentum topic. First, let's list what we know. The mass of the car before, mc, I'm using the subscript c for anything to do with the car, is 1,500 kilograms and its initial velocity is 30 metres per second. Then the van has a mass mv, I'm using the subscript v for van, is 2,000 kilograms and its initial velocity is 0. After the collision, both vehicles move together, so their total mass together is 3,500 kilograms. We've just added the two masses together. And we need to work out the velocity after that collision. So we're going to use conservation of momentum. Now make sure you write this out, it's always worth marks, just saying that you're using that and what it is. So the momentum before is the mass multiplied by the velocity of each vehicle. You do this separately and then add them together. So in total, we get a momentum of 45,000 kilogram metres per second. This is the same after the collision and also equal to the mass of the vehicles multiplied by their velocity together. So we end up with 45,000 is equal to the mass, 35,000 multiplied by the common velocity. So we end up with the velocity being equal to 45,000 divided by 3,500, which gives a velocity of 12.9 metres per second, which I've rounded to 3 significant figures. As we're going to need this value later, I'm keeping the unrounded value in my calculator ready to use. For part B, we just need to work out the momentum of the van before the collision and after the collision, then take the difference. So the change in the momentum is going to be the mass of the van multiplied by its final velocity minus the mass of the van multiplied by its initial velocity. So you can see this works out to be 25,714 kilogram metres per second. Now really, as this is an interim answer, I should be giving that to 3 significant figures as well. So I should have written 25,700 kilogram metres per second. But again, I'll be keeping that unrounded value in my calculator for use in the next part. Now for the final calculation, what is the force on the van? For this, we can use that force is equal to the rate of change of momentum. So essentially, change of momentum divided by the impact time. We take our answer to part B, and we're going to divide that by the impact time, which is 0.025 seconds. This gives us an impact force of 1,030,000 newtons, which again, I've rounded to 3 significant figures. This gives you an idea of the variety of problems that you can get on collisions and impacts. If you want to hear more, like, subscribe and hit the bell. What would you like me to do next? If you've got ideas, drop them in the comments. I'm always happy to take those on board. See you next time.